Hey guys, welcome to tonight's video. We are talking about laws of cosines today. We just finished laws of sines, and notice that with laws of sines, we were working with triangles that whereby we have two angles. So the congruences, what we're talking about law of sines, were either angle side or angle side angle. So notice those two have two angles. But then we're moving on to law of cosines, and really the major difference is the congruency will be different here. So the congruency that we'll be working with for law of cosines will be one that has at least two sides. So we're talking about either side or side angle side, and this is what I'm referring to. So with these triangles, those will be the two congruencies that we're looking at. And then in the bottom here, I just generalized the rules. With law of cosines, we mostly use triangles, which are, where we have those two angles in their side. And then law of cosines has two sides. Cosine, side, sine. Okay, no, nothing's working there. I was trying to make a rhyme, but that's not working out. Also, so law of cosines looks a lot like a Pythagorean theorem. Do you guys remember what the Pythagorean theorem looks like? Well, hopefully, came up with a squared equals b squared plus c squared. So for the law of cosines, again, we're using a combination of the sides and the angles in the formula. So I'll go over this first case here. So you begin with the side you're looking for, at least setting up the equation. You begin with the side that you're looking for. So this would be your unknown. And then that side squared, and just that side squared equals the sum of the other two sides that you have squared minus 2 times the sides that you have multiplied together. They're not squared this time, times the cosine of the angle that you begin with. Now, just something to notice is that, or actually I'll bring up a picture next time before I make any observations. So yeah, the side you want squared equals the other two sides squared minus 2 times those other two sides, just plainly, minus 2 times those, just plain, and then cosine of whatever angle you started with. So notice I started with b on this side, I end with b. The other two sides are combined as they're squared, and I subtract when I take them, I multiply them, and I multiply them just plainly. Whatever I start with is whatever I finish with. Okay, so just take a minute to really take in the format of the law of cosine formula. Well, the only way to practice is using examples. So I'm given this example here where I'm given side length A, side length B, and side length C. In order to make sense of anything, I'm going to draw a triangle. My triangle, I input my B as 5 across from B, that's 5. So I put all this information in my triangle. And then I notice that the angle that I'm provided with is an included angle. And what an included angle means that it's the angle at the vertex of the two side lengths that I have there. So that's a good observation there. So okay, I'm told to solve for the triangle. Okay, I have a side length here, I have a side length, I don't have this side length. Well, I could start with that. So in this case it will be c squared equals the other two sides squared minus 2 times the same two sides but not squared this time, cosine of what I started with was c, so cosine of c here is 20 degrees, and that will give me the side length c. After that, I would need to apply the law of cosine just one more time because I need 2 more angles in order to completely solve this triangle. So let's so I just talked about this part up here. Take a moment to just take that in. And after you reach this point, you have all your sides, and now you need to find all the angles. So if we apply the same, the law of cosine one more time, At this point, we have all the side lengths, so all these are known. The A is known, so I can square that. The B is known, I can square the C squared. I can input that. And the only thing I don't know in this formula is a cosine A. I have one equation, one unknown. I can simplify to solve for that. So I go ahead and square my values, and notice that the cosine here is the unknown one, but the cosine here it has coefficients attached to it. So if I need to solve for it, I can take it over to the other side of the equal signs because it's negative here, so it will end up being a positive on the other side. And I combine all the other like terms, and this leading coefficient will eventually be divided through with everything. That's why it's here in the bottom. And then at this point, I see that I have cosine A, but I'm not interested in cosine A. I'm interested in the value of A itself. So the only way to undo that is to take the inverse, and we get that angle A is approximately 148. At this point, I have two angles. I have angle A, I have angle C, I need angle B. I can use my triangle sum theorem and subtract 180 from the known triangles to get the third triangle, which is angle B, and that will be a little cute one called 15.2 degrees. You can pause this video and try this example. I also put it up here just to make sure that you're practicing correctly. And they told us to solve the triangle, so we've found all our side lengths and all our angles, so we're done with that. And then come to example 2. So example 2, I notice I'm given a side, and a side. That's okay because law of cosines utilizes either the side-side congruency or the side-angle side, so at least two sides. So it looks like when I'm trying to solve for this triangle, what I'll need to do is to find the angles. Well, we can pick whichever we want. We can pick either the case where we start with side length B or side length C or side length A. Well, we just decided to start with A here. The first thing I always do is just write out the formula first because it has lots of variables. After we write it out, then we can start replacing those variables. So if I start with A squared, that means it's equals the other two side length squared minus 2 times just the plain side length cosine of whatever I started with, which is A, so cosine of angle A. After that, I already know all my side lengths. So the only unknown here, so notice B and C are replaced by 7 and 5. The only thing I don't know is cosine A. So at this point, I just need to simplify and solve for A. So I combine these terms and notice that cosine A has the leading coefficient of 2 times 7 times 10, that is 70. That's so, and then it's negative, so I take it over to the other side of the equal signs. That's where the 70 cosine of A comes from. So basically this unit was moved to the left side, and then the constant came over to the right side to join the other constants here. So I've got cosine of A equals -7, but I'm not interested in cosine of A, I'm interested in A. So I've got to take my inverse cosine of, well, first I need to divide both sides by 70. And then take the inverse cosine of -7 over 70, and that should give me that angle A is 95.7. Okay, so I've got angle A, but I still need the two other angles. So we can do this process one more time, but this case, making our either angle B or angle C the main case here, or the case on the left side that we want to solve with, 4. So apply the process one more time. Notice that we made B the main one on the left side here because our goal is to solve for angle B, and only when we start with B can we end with B, which is what we're looking for. And then just simplify to get that angle B is 50.7. If you have trouble with the simplification part, please just come practice with me or show me how you're practicing, so that I can check on that. So at this point, we have angle A and we've got angle B. In order to get angle C, we can use our triangle sum theorem to give us that angle C is 33.6 degrees. So that was all. That's all I have to say about the law of cosines. Yesterday I did introduce a way of finding the area of a triangle using law of sines. Another way here, another way of finding the area of a triangle, which is not a right triangle, so we're looking at these acute and obtuse triangles, is using the Heron's formula. So the Heron's formula uses the three sides, A, B, and C, of a triangle, and it will use something called denoted as S, which is the semi-perimeter. So semicircle means half of a circle. So semi-perimeter is half of all of the perimeter of this triangle. So you add all the sides divided by 2, and that gives you the semi-perimeter, which is S. So S equals this stuff up here. Then, in order to find the area of that triangle, I take the square root of S multiplied by S minus each side. So S minus A, S minus B, S minus C. Notice each component is multiplied across that component. Oops, sorry. And the last component, and then we just gotta put an extra S out here. So S appears how many times under the square root? 1, 2, 3, 4. Okay, so take a minute to really internalize this formula, kind of make sense of it a little bit. Remember what a semi-perimeter is, so the S has to be a semi-perimeter before we bring it under the square root here. So here's an example to practice that. You're asked to find the area of a triangle given these sides. So you've got your three sides. If we're going to use the Heron's formula, we'll start by finding that semi-perimeter. I always think semicircle before I say semi-perimeter because it's just such a weird word. So I add all my sides, I divide it by 2, and I get that that value is 23. Now I need to see 23 4 times under my square root. 1, 2, 3, 4. Yeah, I see that. And so the first time it's just by itself. The next time it's with each parenthesis, which is multiplied all across, minus the first side length, minus the second side length, minus the third side length. And then all I need to do is just simplify this to, and then I get that approximately the area is 96 square units. That's all for tonight. I'll see y'all later.